Hey, good people, welcome back. This is Arthur Morris. I hope that all is going well with you today. In this video, we are going to look at eliminating a variable using the substitution method with the systems of equations in two variables. All right, so the substitution method is just that. We want to isolate one of the variables in one of the equations and then substitute that result into the other equation. So here we have 5x plus y equals 9 and negative x plus 3y equals 11. And it's asking us to solve this by the substitution method. Now, the ideal problem to solve by the substitution method is when we have a particular variable that has the coefficient of 1 and it's on the side of the equation, one side of the equation by itself. Right now we don't have an equation where a variable is on one side by itself. So let's call this equation 1 and equation 2. And let's rewrite equation 1 by subtracting 5x from each side. So that will give me y equals 9 minus 5x. The objective there is to solve for one of the variables. So I'll solve that equation for y. So what that tells me is that anywhere in equation 2, anywhere that I see a y variable in the equation 2, I can replace it with 9 minus 5x. Okay, so let's come down here and rewrite equation 2. Now, since I've solved equation 1 for y, I can replace the y in equation 2 with what it's equal to over here in equation 1. So I can replace y with 9 minus 5x. Now, the reason we want to do that is that so we only have one variable in the equation, and we can solve for that variable and find the value, in this case, of x. Again, our goal is to find the value of x and y, which would be the ordered pair that the two equations have in common. So this is one method to finding that ordered pair. So distributive property here. And then combine like terms on the left-hand side, so negative 1x minus 15x. And then subtract 27 from both sides of the equation. Final step to finding the value of x is to divide both sides by negative 16. So we find that x is equal to 1. Now, we also need the y value because our answer should be in an ordered pair form. So we see from our equation 1 where we changed it or rearranged it that y is equal to 9 minus 5 times the value of x. So I'm going to use that equation 1, the one where I rewrote it to where we have y equals, to find the value of y. Well, now I know the value of x because we just found it. X is equal to 1. So 9 minus 5 would give me 4. So the value of y is 4. So the ordered pair for the solution is 1, 4. And remember, you can check that by plugging that ordered pair back into each one of those equations and making sure that it makes a true statement in both of the equations. Okay, let's try another one. Right, on this problem we have the system x minus 2y equals negative 2. and y equals negative 3x plus 15. Well, this one is definitely set up to uh, be easily solved by using the substitution method because we already have a variable by itself in one of our equations. So you see in equation 2, we have y equals negative 3x plus 15. So I will call that equation 1, and I will call that one equation 2. All right, so since we know what y is equal to from equation 2, I'm going to take that information and plug it back in, or replace y in equation 1 with what y is equal to. So let's rewrite equation 1. Now, from equation 2, I know that y is equal to negative 3x plus 15. So I can replace the y with negative 3x plus 15. So instead of negative 2 times y, I have negative 2 times negative 3x plus 15. And again, the reasoning that we want to do that is so we would have only one variable in the equation that we can solve for. Okay, so I'm going to distribute the negative 2. Combine the like terms that are on the left-hand side of the expression, 1x plus 6x. Add 30 to both sides, so negative 2 plus 30 is positive 28. And then divide both sides by 7. So that tells me that the value of x is equal to 4. Now part 2, remember we have to have the x coordinate and the y coordinate. So now I need the y coordinate, which I can find by using equation 2, which says that y is equal to negative 3 times x plus 15. Therefore, y is equal to negative 3 times 4 because x is equal to 4 plus 15. Okay, so negative 12 plus 15 is positive 3, and the ordered pair would be 4, 3. That will be the solution of that system. And if I were to graph those two equations, the lines would intersect at the point 4, 3. That is the point that they have in common. Alrighty, good people. I hope you found that video to be helpful. I'll see you on the next one. Thank you.